The Pythagorean theorem is what we use to find missing sides in a right triangle. So in every right triangle there's two legs. Here's a leg, here's a leg, and then the side that's across from the right angle is called the hypotenuse. And it's always the longest side of the right triangle. And so the Pythagorean theorem is a squared plus b squared is equal to c squared. If you square the lengths of the two legs and add them together, it will always be equal to the length of the hypotenuse squared if it's a right triangle. So if I'm telling you that something's a right triangle, you can use the Pythagorean theorem to find one of the missing sides, or vice versa. If you're trying to check and see whether or not something is a right triangle or not, if you plug the sides into Pythagorean theorem, the two shortest sides squared and added together should be equal to the length of the longest side squared. So you can check and see if something's a right triangle. So you might be wondering, why is the Pythagorean theorem true? This diagram down here is an example. It's kind of proving it to you. So think of this right triangle right here. The length of this side, this leg, is 3 units long. The length of the other leg is 4 units long. And then the length of the hypotenuse is 5 units long. So envision that we've taken the lengths of the sides of the triangle and created squares. So this is a 3 by 3 square. This is a 4 by 4 square. And then that's a 5 by 5 square. So if you're trying to find the area of those squares, the area of the little square is 3 times 3, which if you can count all the squares, the area of that square is 9. The area of the second square, 4 by 4, is 16. And then the area of the big square is 25. 5 times 5 is 25, and you can count all the squares. So if you think a squared plus b squared equals c squared, 3 squared plus 4 squared should be equal to 5 squared. Well, we know 3 squared is 9. 4 squared is 16. And that should be equal to 25. Well, 9 plus 16 is indeed 25. 25 is equal to 25. Ching! So this is just a visual representation of that. If you were to take the sides of a right triangle and then extend them out and create these squares, you could literally just count up all the boxes, add them all up, and the blue squares plus the green squares would add up to the red squares. The next concept is called a Pythagorean triple. Pythagorean triple is 3 whole numbers, so 3 integers, that create the sides of a right triangle. So if you plugged 3, 4, and 5 into the Pythagorean theorem, a squared plus b squared would be equal to c squared. The two shortest sides squared and added together would be equal to the longest side. So it's 3 whole numbers, 3 integers that create a right triangle. So no decimals, no fractions, definitely no negatives, because the sides of a triangle can't be negative, but it's these whole numbers. And not only is it just these whole number combinations, but it's the multiples. So like 3, 4, 5, those are the sides of a right triangle. If you double them, 6, 8, 10, that will also be the sides of a right triangle. If you triple it, 9, 12, 15. So you can take these Pythagorean triples and multiply them and scale them out, and all of those will also be Pythagorean triples. So some common Pythagorean triples that would be beneficial for you to memorize, especially when you get to pre-cal, are these: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And then the multiples of those. So you can sort of start to recognize patterns. Like if you see 16 and 30 and you're like, oh, what's the third side? What's the hypotenuse? instead of plugging these rather large numbers into the Pythagorean theorem and then having to do all that computation, if you can just recognize that that's a multiple of this Pythagorean triple, you can just think like, oh, 8 times 2 is 16, 15 times 2 is 30, 17 times 2 would have to be 34. So you essentially can avoid having to do the Pythagorean theorem if you can just memorize these Pythagorean triples and then start to like catch on when you see their multiples. So some common Pythagorean triples, ones that are beneficial for you to memorize, are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. And obviously the two short sides, the two smallest numbers represent the legs, and then the longest one is the hypotenuse. So leg, leg, hypotenuse, leg, leg, hypotenuse.